where the real mess is. So, and our last speaker is going to be Henk Rogers, and he's going to be tuning in probably a little bit later. He's got some other stuff going on, and so he'll be coming in. But he runs Blue Planet Foundation. He's the founder of Blue Planet Foundation, but he also runs a couple of other companies like Blue Planet Energy and Blue Planet Research on the Big Island. And Blue Planet Research, I'm still engaged with on hydrogen and lithium ferrous phosphate battery technology. So we still work with him on that stuff. But he's a space junkie. He likes anything to do with space. He's a big fan of Elon Musk and SpaceX, and he runs a habitat on the slopes of Mauna Loa for training astronauts. And NASA had him under contract for about 4 or 5 years, running a Mars habitat where they would run astronauts through the habitat. The longest mission was a whole year, where they had to literally live in that thing for a whole year. And it simulated, there's a 20-minute delay in radio transmissions. So they would literally delay transmissions, and before they could go outside their habitat, they had to call and ask permission to get for an EVA, and then go get into spacesuits and then go outside. And outside, of course, is all just volcanic terrain and lava tubes and stuff. So it's a pretty complicated operation, and he set it up there to train NASA folks, and now he's training international folks. So looks like we're getting quite a few folks on, and it's 10:31. So I guess we can get started. Michael, do you want to start off with any words first?
Yeah, I'd like to thank you all for coming, and thank you to all of our presenters. And this is a great new topic for us, the Hawaii space industry. And say that every 50 years there's a dramatic change in Hawaii industry, and it'll just flip from whaling to agriculture, and then flip from agriculture to tourism. And maybe the time is now that we're going to see a flip to space as a new industry for Hawaii. So thank you all for coming and participating in this Renew Rebuild Hawaii forum. And Stan, I hand it to you.
All right, thanks, Michael. So we've got a great setup today with actually 5. We added one more presenter on at the end to talk about economic development piece of this, as Michael mentioned. But I'd like to lead up into this by saying, I'm not a big economics wizard, but I can tell you, living in Hawaii my whole life, that we've had tourism and agriculture and the government, military in particular, being big parts of Hawaii's economy for many, many years. But when pineapple and sugarcane went away, we lost a big part of our export economy. And that hasn't really been replaced by agriculture, to help us sustain ourselves. And that's a big push I know the state's working on right now. But also, tourism showed its frailty in this last pandemic, when all of a sudden we didn't have tourists for a long time. So the point being that we had our 3-legged stool, military, agriculture, and tourism, supporting Hawaii's economy for many years, and now we don't. We can't always count on tourism. We haven't really recovered on our agriculture side. And the military and government spend a lot of money here, but that could go away too, depending on the whims of government and the military, especially if they pulled a lot of the Army out of Schofield and shut down training areas. That would really impact Hawaii's economy greatly. So we do need to look for ways to improve our economy. And if you look at the title of this presentation, it's space technology and energy. And those are 2 areas we'd like to kind of look at and focus on the space side today. But if we were energy independent and we're not importing a lot of oil from elsewhere, that would have a huge impact on our economy. And maybe Eugene can talk a little bit about that. But the space operations may be another area. And, like anything, we feel like we need to publicly air those thoughts before anybody gets real serious about leaning too far forward in the space saddle. And make sure that it makes sense for Hawaii, make sure that it's a cultural fit, an economic fit, environmental fit and geographic, everything, do as good a critical analysis as we can. So we brought together some folks we think can talk about that. And we'll get started with Eugene Tian from the State Department of Business, Economic Development, and Tourism, and let him talk to us a little bit about space and Hawaii's economy. So Eugene, you got it.
Okay, thank you, Stan. Let me try to share my screen. Let me know if you are able to see my screen.
We got it.
Okay, I'll run the slideshow from the beginning. Okay, the space industry. So there is no definition in the worldwide what is a space industry and what is the difference between aerospace industry and the space industry. So I just pick up two definitions, and usually in the past so many years, DBAT, my department, actually had two agencies. They do research and functions on the space industry. And one is called the Office of Aerospace Development. We call it OAD. So that office was transferred, the function transferred to the University of Hawaii system 5 years ago. And we have another agency, is called Pacific International Space Center for Exploration Systems. In short, we call PICES. That organization was transferred to the University of Hawaii Hilo last year. So now DBAT doesn't have agency to deal with or a function for aerospace. But that means the aerospace industry was on the agenda of DBAT economic development. And let me give you a few numbers. The Hawaii GDP total amount is 100 billion. And let me give you another number. Think about the film industry. It's 300 million. So that industry is $300 million of business. And I will talk about the space industry. So like tourism, like energy, like creative, any other industries, they are not in the North America industry classification system. We call NAICS. We have to define them ourselves. For example, what is included in tourism? I think in the world, there is a consensus on how do we measure tourism. So basically, it's measured by transportation, lodging, food services, retails, because not all of them are tourism only. For example, the retail and also food services. There's a lot of component by local residents. So the measure is need a special calculation. For the space industry is the same thing. What's included? So let me tell you the first definition is by Aerodynamic Advisory. So they define the aerospace industry include all in-country activities. That means it's international, it's not included, especially for the airlines. Pertaining to the development, production, maintenance, and the support of aircraft and the spacecraft. So this including the aircraft, so including airplanes. And the definition by Hawaii Aerospace Development Office, and that's, we are talking about 10 years ago, is the design, manufacture, use of aircraft, rocket, missile, and the spacecraft that operate in Earth's atmosphere. Support services, including those education, training, and those are also included. So the definition for the Aerospace Development Office is much broader than the definition of aerodynamics. Let me give you some numbers. Look at it, this number is by the Aerodynamic Advisory. So as a comparison, I pull out both 2017 number for both definitions So this is for global, is about $838 billion of business. This is talking about only the manufacturing of the the whole equipment and the parts. So 28% is the manufacturing of the full equipment, original equipment manufacturing. So then the second 27% is the civil military. Those are the components, and aircraft system component. So we have, you can see the satellite and the space is 7%. So this study, they also provide the ranking by country. It's actually about 49% that year. 49% is accounted by the US. US accounted for 49%, almost half. So the number one is US, and number two is France, and number three is China. So this is the aerodynamic advisory definition. And this definition is by the Office of Aerospace Development of DBAT. And their definition is broad. It's mainly including 73% of the airlines, including the operation, is $4.5 billion. So the contribution to the economy in that year was 5.3%. So it was pretty big. But by component, you can see there is IT, information technology, there is defense 5%, including education, including training others. We do also have every year, and we have the tax credit. It's called the high technology. I think currently we call the research activity tax credit. And the business is fighting the tax credit on the annual basis. My office, we produced a report based on the fighting since 2013. And you can see the numbers. The business is fighting, we call these high technology, qualified high technology business. So they filed the, in the past, it's about 10 companies. Between 2013 to 2019, about 10 companies fighting for the tax credit. And for the year 2020, is jumped to 40 companies. Is because the tax credit increase. The average tax credit issued is about 3 million each year. But by the year 2020, they increased tax credit to 5 million. And it is still 5 million currently. So the companies fighting for the credit increase from 10 to 40 in 2020. So that's why you see the 2020 number increase. But when you look at the blue number, those are the companies claim they are doing business or research in the aerospace. These are the numbers they are spending or investment numbers. So you can see the number increasing, but sometimes it has a little decrease. In 2019 was a big increase to 31 million. And overall is about 20% is from the aerospace. Out of all the technology firms we call qualified high technology business, is about 20% of them fall into the aerospace. And altogether, you can see the total for 2020 is about 195 million. And that's why I was telling you at the beginning, compared with some industries like film production is 300 million. So this industry is, we do have the industry, it is growing, and I think it will need more support. I do see some report from California. So California was claiming that we know a lot of products consumed in Hawaii were from California, especially they produce the food. And also we know California, especially LA, is a major film producer located in Universal Studio. So what they claim is that the agricultural and the film production together combined is smaller than the space industry. So the aerospace industry in California, they actually is a big component, and they hired about 30% of the NASA scientists in California. So it is a growing industry in other states, but in Hawaii, we see is pretty much stable around the 10 to 12 million in the past. There was an exception for 2019 with 31 million. And by category, I look at these findings, how they spend those money. The bottom line is it has the number of firms they claim that they do research in the aerospace, and the total amount of money spent is on the yellow highlighted line. Is the same as the bar in the previous, but by category, you can see that the spending is in communications, computer systems, modeling, simulation, training, and photonics, testing, evaluation. You can see 2019, the main increase is actually in the testing, evaluation, and in our survey, and also we have some confidential data we cannot release. And there was a big increase at 22.4 million in the testing and the evaluation for that year alone in 2019. And we do see some special software development and many years. That's one of the largest spending. And we also see the next slide, 2 lines, especially the line of unmanned vehicles robotics is also started in 2017. The spending has go up to 4.2 million in 2018, and 2019 was 2.8 million. So 2020 it wasn't. Is a year of the COVID pandemic. There was some kind of decrease from 2019, but is in line with the other years, is around 10 to 12 million dollars. I think that conclude my presentation. Basically, the industry has been in existence and need more development. I think now the function mainly is moved to the University of Hawaii system. Thank you.
Thanks, Eugene. And I had a quick question, if you happen to know this off the top of your head, but do you break down any of the data by island, like Maui, Kauai, Big Island, Oahu? What percentage of those things? I know you don't have it off the top of your head, but do you break that data out by island?
Yeah, we do. When the companies are filing for the tax credit, they did tell us where they are. And some of them, most of them are in Hawaii. Some of them are even located on the mainland.
Okay.
Yeah.
All right.
We do have those data by, actually we have a data since 2013. It's called a report on tax credit for research activities. We have every year on the DBI website, there is a section called Report to Legislature. So those reports are there. We even report every business, the name of the business, but I cannot tell which one is in, because of the confidentiality, I cannot tell which one is in the aerospace. But for the number of companies, about five of them do research in the aerospace area. Is actually only one company. They define themselves as an industry in that, specifically in the aerospace. So it's about 1 or 2 companies. They said they are in this industry, but others, they do research in the aerospace, but they don't define themselves as in the sector of aerospace.
Okay, all right. Just for the audience too, and I think there might be a parallel here. I know in the aviation industry, which is part of the aerospace industry, one of the I don't want to call it a technique, but one of the things I've noticed in aviation is that when the military, for example, builds an airplane, they like to have the parts come from as many different states as they can, because then they know they can get political support in the Senate for appropriations and things if an airplane, for example, has parts built. And people would be amazed to understand that even the C-17 has some parts built in Hawaii. And that's how those companies garner federal funding and federal support, is because they even have parts of the airplane or subsystems built in as many states as they can. So that's one of the things that dovetails into Eugene's comments, that even though some of these companies may seem like a small percentage or only tangential with computer programming or something like that, they all add up to a lot when you're trying to bring the federal dollars in for federal programs or get support from companies that look at the federal government for regulations and things. So our next speaker is General Ryan Okahara, who he's kind of a chameleon, because he's also a kind of important guy in the federal government for was it HUD, Housing and Human and Urban Development? Is that it? Okay. And but Ryan has the unique distinction of being probably one of the only actual space cadets in the state of Hawaii. He's when you say so, you know, like you want to have somebody that's an astrophysics major, or you want a really big brain in space. We hired Ryan in the Hawaii Air National Guard, I think as a captain out of the Air Force, and he's literally a rocket scientist, and there aren't a whole lot of them in Hawaii, but we figured he'd be the guy to talk to about what makes sense from a physics standpoint and an economic standpoint and a military standpoint and a civilian standpoint, with Hawaii dovetailing into space. So Ryan, take it away.
Thanks, Stan. Again, good morning. My name is Ryan Okahara. As Stan said, I was one of those folks born and raised in Hawaii, went on active duty in the Air Force, but really went to what at the time was Air Force Space Command. All of that's changed. I'll kind of give you a brief overview of that, and then I'll dive into what we already have space-wise from a military perspective, and then touch on some opportunities that I think we'll have in the future. So today, or I'm wearing an Air Force uniform, but you wouldn't be able to tell the difference. Today, we have a U.S. Space Force. It's just like the other branches of the service, Army, Air Force, Navy, Marines, and now the U.S. Space Force. It's not a joke. It's a real entity. They organize and equip all of our space forces that we apply. And I'm going to go over one slide in a few minutes just to kind of give you that breakdown. The U.S. Space Force 2.5 years ago and is largely focused only on space. Most of my career as a space operations officer, I served under pilots in the Air Force. This is an opportunity for us to kind of break out, work under space professionals, and focus just on the area or the domain of space. For us, from a military definition, we use that as 100 kilometers up and higher, all the way out to the sun, if you will, and even beyond. And we're focusing on those types of missions. I'm going to put up one slide, and I'll just talk about that briefly, assuming I can get this up correctly. Okay. And Stan, if you could just let me know if you can see it.
Not yet. Oh, it's coming. There we go. We got it.
Okay, from a structure standpoint, this slide is about a year old. I gave you a little background about the Space Force just because it's changing rapidly. It actually changes every time I'm out there. It's changed and our organizational chart changes accordingly. I'm going to start with what we call deltas. In the Air Force, we used to call them wings, and we'd organize them by usually geography. In the Space Force, we group them by function that they perform. So specifically, the first one that you see is Star Delta. That has become its own what we call field command, and STAR stands for Space Training and Readiness. They do research and development, test and evaluations, and then also recruiting and our personnel things. But from Space Delta 2 on through 9, I'm going to just briefly touch on what that means, because those are the opportunities and in some cases, missions that we already have in place. So the first one would be Space Delta 2, and under it, it says SDA. That stands for Space Domain Awareness. Used to be called Space Surveillance. It's basically knowing what's up there and what it's doing. So we have, for example, telescopes on Maui that look up in really clear skies and look at satellites as they fly by, trying to figure out what do they do. It also is there to look at different pieces of debris to make sure that we have everything accounted for that we can see. And that's, think of air traffic control and deconflicting space. That's under Space Delta 2, Space Domain Awareness. The second one over, which is Space Delta 3, it says SEW. That stands for Space Electronic Warfare. So all that means is another type of warfare. We use electrons to do offensive and defensive operations. For those who used to fly, you could fly an aircraft and emit electrons and jam radars, as an example. That's pretty much what Space Electronic Warfare, or Delta 3, does. In Hawaii, and the Hawaii Air National Guard in particular, we're standing up a Space Electronic Warfare, or really an electronic communications squadron, or electronic combat squadron on Kauai. It's going to be an 88-person unit, 30 full-time job opportunities. They're really already placed on parking sands, or PMRF, what we call PMRF out there. The next one, Space Delta 4, is MW, that's missile warning. So one of the missions that we're looking at putting in Hawaii was the Homeland Defense Radar Hawaii. It's a discrimination radar. We looked at, Missile Defense Agency looked at putting it on Kaena Point. Now they're looking at putting it on Kauai. All it is, if you think of a big radar, sends beams into the sky to see if missiles, break that beam, it starts to track it. That's a mission that we could get. We're just not sure if it's going to get funded or not at this point in time. But if it does come to Hawaii, it's going to be on Kauai again, and it will be just about the same spot in Barking Sands. Space Delta 5 is command and control. That's at Vandenberg, and you can see it says AFB. Those have all changed to Space Force bases, so they're no longer an Air Force base, but they do all of the command and control of all of our forces, predominantly from Vandenberg Space Force Base. Delta 6 is what we call cyber operations. So if everybody thinks about space professionals, you should immediately think about cyber, and you should immediately think about intelligence. That's pretty much what makes up our very small Space Force at this time. And Space Delta 6 also includes our tracking stations, our satellite tracking stations that download information from our satellites that are orbiting and also send commands to those same satellites. One of those sites for satellite command and control is on Kaena Point on Oahu. So at Kaena Point Satellite Tracking Station, we have antennas constantly talking to satellites and bringing that data down as well. So that's a mission we already have on Oahu. Space Delta 7 is intel, surveillance, and reconnaissance. I'm not going to talk about that very much, mostly because of classification issues, but that's a organization that really focuses on how do we gather that information, how do we analyze that information, and then get it out to the people who need that from an intelligence perspective. Space Delta 8 is satellite communications and navigational warfare. What does that mean? We have a lot of secure satellites that communicate and send secure data and communications information back and forth around the world. And then the navigational warfare is GPS. Right? So it's global positioning satellites that tell us where we are in the world. Very important from a civil side, just as much as on the military, because navigational satellites do everything from your cell phone telling you where you're at to time and sequence things like your teller machines at the bank, and also drive a lot of combines and farm equipment, that are done and tracking how they're laying down crops, on a very large grid. The last one I'm not going to talk much about because it's the newest. It's called Space Delta 9. Space Delta 9, and that OW stands for orbital warfare. Up until a few years back, space professionals, we didn't talk about offensive operations in space. Orbital warfare is now saying not just providing space services to forces on the Earth, but also what about things that are flying in space and really engaging in space? So orbital warfare, think of the folks that are defending the high ground and defending our satellites from enemy and aggressive adversaries. So that's kind of the structure we had. I've already kind of talked to you about two of the units that we have. One, again, space electronic warfare, that's going to be on Kauai, missile warning radar that could go to Kauai. We also have the satellite communications terminal out at Kaena Point, we call it Hula. And then the last one I didn't mention, which is really space domain awareness, is on Haleakala on the island of Maui. We have good quality telescopes there and other equipment that looks out into space to try to track and then also identify what's in space. Tracking is not just looking at other satellites, it is looking at debris that could be the size of a grapefruit. And what we want to do is make sure we know where that is, because we don't want it colliding with any of our satellites. We also don't want it to collide with the International Space Station. Again, I'm going to step back and tell you opportunities. So one of the questions that I think Stan had floated to me is, where would our opportunities be for furthering space? And the first thing I'll tell you is that Kauai, I think they have a pretty good opportunity just in Barking Sands, because the Navy runs a lot of tests. They also do launch missiles there for testing. They also have an Aegis Ashore radar that's out of Kauai. And then you can also see some of the new missions that may be going there as well. They also have a good location because they're far up north. They're not surrounded by a lot of other land masses. So if they were to do space launch, it would be a pretty good location to launch things into what we call a polar orbit, think north-south. The other opportunities are always going to be on Oahu. We have a lot of, I think, more on the cyber space side that could come to Oahu. We could put additional satellite communications or satellite antennas on Kaena Point. I'll go to Maui. Maui is a great location. So the Big Island, from being high up on a volcanic mountain, above the clouds, above the humidity, very little light pollution. And we could put a lot of space domain awareness types of resources and equipment there. And then the Big Island, same kind of concept as Maui in terms of having high mountains that you can put things on. We know the politics about that can be difficult, but they also have South Point, which is, again, the closest point to the equator where you could actually do space launch from there as well. If you think about space launch, you want to get as close to the equator if you're going to throw things into a east-west or a west-east type of motion. You want to be close to the equator, you're at a higher speed, and you can lift things into space at a lower cost. I'm going to pause there and see if Stan has any questions or if anybody else has any questions, and then I'll be here to answer as we go along.
Thanks, Ryan. I do have one. It's kind of a two-part thing. Is, right now we have different kind of fuels in rocketry, and for a long time we've used hydrogen as one of the primary fuels. But I've also heard that for some of the civilian rocketry, we're using kerosene, and that's probably a cost thing. But with the price of fossil fuels going up and up and up, could liquid hydrogen come back into play as a viable fuel for rocketry?
In reality, I think hydrogen still is the primary source of fuel that we would default to if we're going to use liquid fuels. So hydrogen is very good because it has high energy concentration. So for the amount of weight that you're carrying, it burns hot. It gives you a lot of energy. The downfall with hydrogen, especially on the first stage, you always hear of solid rocket, is it's hard to work with, and it takes up space. And if it catches on fire, it's catastrophic. So a lot of times, the first stages of bigger rockets will use solid rocket, which means a mixture already combined, which the positive for that is once you light it, it goes, and it's inexpensive in relative terms. The bad thing is you can't turn it off. Right? Once you light it, it goes until it's exhausted. While hydrogen, we usually use that on second stages or actually on the satellite itself. for propulsion, because you can turn it on, you can turn it off, you can let a little go or a lot go, and you can also steer it. So I think hydrogen's still always going to be a primary source. Kerosene, why do people use kerosene? It's cheaper, it's more stable, right? So you can handle it easier and it doesn't explode, if it leaks or mixes with oxygen.
Great, thanks. That's a really good breakdown, because I've heard that we've kind of gone more to solid rockets and using kerosene when we have liquids, but I had a feeling that it was mostly economics. What are some of the you talk a little bit about what the military does in the different islands. What are some of the civilian jobs that you can see dovetailing in, and even some that Eugene brought up, like on the computer side and programming side and tracking debris side, that you envision for Hawaii?
Yeah, I'm not going to say that it's only for Hawaii, but the commercial and the civil space industry, I think, is actually going to be growing much faster than the military side. And that's always a good thing, by the way. So the first thing has been, and the largest area where I think the civil market's been in has been communication satellites. A lot of the bandwidth that's up there is civilian, which is a good thing. The other thing that civil markets have already been doing is Earth observation. Right? So it could be looking down. You could call them spy satellites on the military side, but when you're using it for looking at weather or crops, civil satellites have already been involved with that. One of the things that I'm really interested in hearing Alex later would be reading on the space debris. Right, so we talk about not just being able to identify what's up there, and we want to get it down to small little objects that are a centimeter in size, traveling at the speeds they travel at in space will take out the space station, will definitely take out the satellite. So how do we best track that? And then eventually, how do we remove it? So space debris removal, I think, is going to be a space support service in the future that's going to be a huge market as soon as we figure out who's going to pay for it. Right? Because we know people want that. We got to take stuff out, but who wants to pay for that? So I vote that we charge the Chinese and the Russians who blew up satellites and caused all the debris, make them pay. But again, that's not something that most people would agree to, especially Russia and China.
Alex Fielding is clapping and saying you're right on there. So
I'll probably see you again, Alex, but I want to hear that discussion anyway. But the last area, so Stan, we talk about space, what I would call space support services. Think about in the Air Force side. What do we do with aircraft? We refuel them. Right? One of the biggest limiting factors that we have for satellites is the amount of fuel we can take on them. And once it's exhausted, what do you do with it? So in the future, we might have industry that civil companies that'll say, hey, I'll go up and I'll refuel your satellite. Or I will put on an engine on it, a motor that allows you to move it, because maybe right now it can't be moved. Or in the future, maybe you can deorbit your satellites and get rid of that trash so it doesn't just float out there forever. Those are, I think, opportunities for civil sectors probably going to take the lead on a lot of those. If there's money to be made, and you can talk about mining and all those other things when you get out there, but if there's money to be made, I think the commercial and civil sector will be better at it than the military. And space launch is a prime example today in space tourism.
Yeah, I would say the civil sector is already proving that with how effective they're putting things into orbit. So, well, thanks, Ryan. I hope you can stick around for some Q&A.
Stan, one question on the space launch discussion. I was looking up some information, and when I was a young officer, it would cost us anywhere from $2 million and up per pound to put it into space, especially the orbits we were using. SpaceX today is probably costing about $2,500 a pound. So you can see the order of magnitude. Someday it's going to be a few dollars a pound to put things into space. And that's when I think we're going to need things like a spaceport, because it might be cost effective to move cargo at that kind of expense rate. Thanks a lot.
That's a good point. I hope you can stick around. I know that Hank's going to tell us about something he put into orbit a little bit ago, so we'll hear from him on that one. But next up is Alex Fielding, and he's going to talk to us a little bit about his Maui-based company that's actually already doing some work in the space junk world, as it were. And so, Alex, welcome, and we're looking forward to your comments.
Yeah, thanks so much. And Ryan, I totally agree with you. I think I think those people who put the trash up should have to pay to put the trash out. And I certainly, I certainly agree. Especially, I've decided I'm now completely in solidarity with our friend in Ukraine here, and I'm sure he would have agreed even after Cosmos 1408 last year was blown up in that ASAT attack in November. So I'm Alex Fielding. I'm the CEO of Privateer Space. We're headquartered in Maui. We got started here about 1.5 years ago, focused on a lot of the challenges of space situational awareness, domain awareness, and traffic management. But this week is a big week for us because we have been in stealth mode for 1.5 years, hiding in the Maui Economic Development Building, and working tirelessly on not just our software, but also on our in-orbit assets, which will be going up. Some of them will be going up this year in 2022, which we're really thrilled by. Privateer was started in the usual way. Space is a little bit like the mafia. Every time I think I'm out, it pulls me back in. And I actually got my career started in the space industry working on intersatellite routing between LEOs and MEOs and GEOs, and then left space for a brief moment. And then Waz and I started a company in 2001, hard to believe, 21 years ago, doing GPS locator tags, basically building Apple tags 20 years too early. And at the time, the reason I tell the story is you had to do everything yourself. You had to do the hardware yourself. You had to do the software yourself. You had to do ephemeris calc yourself. You had to figure out, really how to make that a package. And 20 years ago, we had maybe 2,200 things on orbit, and maybe half of those were trash. And we used to joke, maybe someday we'd be the world's first space sanitation engineers, and we'd ride on the back of the garbage truck and we'd toss satellites in the compactor, and wouldn't that be great? But, fast forward 20 years, and it is, the definition of the tragedy of the commons. Because not only did the problem get much, much worse than it was 20 years ago, but the solutions are few and far between. And our state of space tracking is not as good as it should be. And it's certainly worse in the commercial sector than it is in government and in the intelligence community. What you're looking at here is what we call it Privateer Wayfinder. So everything, if you can see my screen, everything here that's an orange dot is an active satellite. Everything that's a teal dot is a dead satellite. And everything that's pink or purple or gray is some form of catalog space debris. Like Ryan said, that's generally larger than 10 centimeters. It's bigger than a softball. And even though you can't see it easily, if I zoom in, you'll see that our live tracking, it's not exactly live tracking, but we've got some orbital determination and some live tracking over ground stations. And you can see that these dots are actually moving. We can zoom out here, and they're still moving, but I can speed this up so you can get an idea for what that actually looks like. And the reason I show this is that if we looked at any of these assets, we can see some data about them. We can look at some catalog data. We can look at some tracking data. And in many cases, we have multiple sources of tracking on each of these satellites from multiple ground-based systems, and soon some space-based systems as well. If I want to cheat and find something that we actually have more than one source of tracking on, we can cheat and go look for flocks. Oops. And we'll pick a couple at random here to just take a peek. And what you'll see is really interesting, right? A lot of our space tracking today is done using ground-based radar or phase array and sometimes optics as well. And what you'll see is that orbital speed, mean motion, and period, which are all calculated really based on speed, how often is this thing going to circle the globe? We are in pretty tight alignment between, in this case, the data you're looking at on top is Air Force US Space Command high resolution catalog tracking the object, and below it you're looking at a Planet Lab. I just kind of picked one at random, Flock 3P22, and you're looking at their onboard GPS transponder telling you how fast they think they're going and calculating the same thing. And you can see it's great. We agree. It's doing 0.0642 degrees a second, 7.7 kilometers a second. Things basically going about 18,000 miles an hour. It's great that we agree on the speed. But if you look at argument of perigee, Planet says this thing's at 73.3356 degrees. US Space Command says, no, it's not. It's at 72.1291. That's not a huge delta, but for those of you that can do that math in your head, we're probably talking about a deviation here that's over 50 kilometers. But the average mean deviation in the space catalog between our best sources of ground-based tracking is 200 kilometers in LEO. And, you know, to Ryan's point about space support services coming, we basically built the highway system to the stars. We radically reduced launch cost down to a point where it's almost free to put stuff in space. I mean, my launch cost commercially is about $5,000 a kilo. And I can bundle in the cost of my launcher and other things to launch my small sats. So at $5,000 a kilo, people are putting things in space that certainly are new to space, and some things that probably don't even deserve to be in space. But the challenge becomes, great, we built the highway to the stars with SpaceX and others competing. We didn't build the restrooms or the Mickey D's or any of the infrastructure. And now the space support servicing companies and the in-orbit servicing companies are coming rapidly. But how do you do refueling or tug tow or station keeping if you don't agree on where all the objects are, and if we don't have persistent real-time tracking on the objects? And there's better tracking in US government, but it's not available to the commercial space community. And in the commercial space community, most of these companies are emerging very, very fast. And the opportunities are emerging equally fast. You know, 2014 was probably the breakover point, where in a single year, we saw things launching into space flip from 80% government and 20% commercial to literally flip to 80% commercial and 20% government. And if you look at last year, 2021, it's the first year in my life where we've seen a doubling of in-orbit assets. And it was about 90% commercial, you know, largely thanks to SpaceX and radically reduced launch cost. So how in the heck do we start to close the gap on all of the problems we have in LEO? Because this first problem of just knowing where things are, including debris, and being able to see debris smaller than 10 centimeters, be nice to get down to a millimeter. That would be a good starting point. So one of the things that we're doing is we're putting up our own constellation of small sats, and also asking partners to fly our hosted payload, our sensors from our small sats. And we call those, you know, PONO, because we are trying really hard to do the right thing. And I think that these satellites, you know, for a small chassis, for a 3U chassis, we've been able to pack 42 sensors in a 3U bus. So we're trying out new sensing approaches to just be able to first sense and detect things in space, but ultimately track and monitor and predict and plan how things are moving in space, and also assist people who are doing in-orbit operations so that they can do their job better. And this includes the people that are trying to clean up space today, right? Great companies like Astroscale and ClearSpace. There's a lot of people doing really good work in space. It also can include people refueling things in space like Orbit Fab and others. You know, I mean, how in the world do you drive the trash truck to the trash can if you have to drive it around in a 200-kilometer circle to find it? Oftentimes, it's really quite tricky. The other thing that we're doing is we're opening up these data, not just from our own tracking, not just from other publicly available tracking, but also from companies that are private companies that sell this data for a living. So we're incorporating that into the privateer platform, which we call Wayfinder. And, you know, we're starting to see really good traction with companies that are working in partnership with us at Privateer. So as an example, we have a partnership today with Astroscale, Virgin Orbit, Big Bear AI, and others, where we're helping by placing our PONO satellites in orbit within a 300-kilometer distance of their target, and then determining things like tumble rate, spin rate, and helping them with our far field sensing and midfield sensing to be able to do maneuver planning to go and capture a target that they would like to cooperatively rendezvous with. all of these things and all the things that developers can use these data with are things that we hope to enable through Privateer in a way that we can combine resources and share resources so that we don't put a ton of additional stuff in space, right? I mean, everywhere that we can, we're asking for help flying our payload, flying our sensors. And those sensors are, some of which have been space flown and are well known, like continuous and passive radar. But some of them are more sciencey, I mean, that's the technical term. We're flying things like nano F tier, Fourier transform IR, sub-millimeter wave Schottky diodes, a photon counter, and we've got some optics. I mean, they're not particularly great optics, but we're flying a wide lens and a zoom lens, so 10 millimeter to 200. And what we're learning through this process is that, most of the people we've met in the space community are absolutely fantastic. And they are more than willing to not just share data wherever they can, but they're willing to help us to keep the number of things in orbit down to the absolute minimum so that we can build this sensing network around planet Earth that can persistently monitor things in space. One of the other things we're doing, and we haven't announced it yet, but it's coming really soon, is we're releasing a conjunction streaming service. So we're taking live telemetry and state vector data, and we're calculating the likelihood of things becoming conjoined. Now, that could be things that are intentionally going to be conjoined, like, docking at the space station. It could be things that are not intentionally designed to be conjoined or to collide with each other, which what you're looking at here is a 20-minute forward snapshot using live TLEs and state vector for a whole host of companies that are providing us their TLEs and vectors. And, on the left, you're looking at distance to conjunction. So the bottom of the chart is the closest. And to the right, we're only looking at a 20-minute snapshot. To calculate 20 minutes ahead, you can see we're using over 5 gigs of active RAM. To get 24 hours ahead, we consume about 2 terabytes of active RAM. To get 72 hours ahead, we're at like 10 terabytes of active RAM and 20,000 CPU cores. This is a very, very, very compute heavy application. And if we look at any of these dots here, green are basically satellites in each other, yellow are satellites on debris, and red is catalog debris on each other. And we can look at these objects, we can interrogate what are they. So here we can see this is Cosmos 1876 in risk with Feng Yun 1C debris. I mean, at this point, not particularly high risk, but we also have to acknowledge that the data sources mean that maybe in this system we're 1 in 1,000 likelihood of in terms of accuracy for conjunction. That's probably 10 times better than what most companies and operators require to decide if they move an asset. We can also show this data on a map, and we soon will be overlaying this onto Wayfinder for Privateer. So in the next 60 days, we'll be turning this open. But we've got roughly 2,000 commercial assets delivering us live TLEs and state vectors to build out this conjunction service, which we call RELSEC, which is Kessler spelled backwards. So this is coming soon. And we also announced some things that are just more fun this week, which is that we're in a partnership with Omega. I look like the bouncer, and it looks like Moraba and I are sitting on Waz's lap and asking him for wishes. But it's still a fantastic partnership. For those of you that aren't familiar with Omega's kind of history in space, I mean, they started during really Apollo 8. And in fact, an Omega wristwatch was used as the original timing for photographs from Apollo 8. So you'll see when, before EXIF data existed with digital cameras, Omega was in the shot for the satellite images. They've been wonderful to work with. They also, I spent 5 years at NASA, and the most prestigious award you can win at NASA is the Silver Snoopy Award for space safety. Omega is one of the only vendors that's ever won a Silver Snoopy, and they won it for their contribution to Apollo 13, which is really great. And
Alex,
we
thanks. I really appreciate you sharing. And I think for the takeaway from your presentation is, I don't know how many people are aware of the kind of sophisticated work being done in Hawaii in space already. And I think, you just gave everybody an eyeful and an earful of some really impressive work that's being done on Maui. And I don't know if you had a chance to go down to Photonics lately and talk to those guys, but we actually have another company right down the street from Alex that actually did the ground the lenses for the Hubble telescope in space. We already have some great industries in the state that are doing space work, and we'd like to really congratulate you for what you're doing. And one question, you quickly mentioned that you and Woz back 21. Who's Woz? Tell everybody who's Woz.
Steve Wozniak was the co-founder of Apple, but he was the engineer behind it, and Henk, he's also a massive Tetris addict. So it's a little known fact that about 20 years ago, I shouldn't even tell the story, but Steve picked up the phone and called me at 11 o'clock at night and said, "Hey, do you remember when you told me that if we ever had the opportunity to play Tetris on the side of a building, you would be there?" And I said, "No, I don't remember that." And he said, "No, you did. And if you don't go with me first thing in the morning to Brown University, where they've wired up the 14-story library building with Christmas tree lights and relays, so we can play Tetris from across the street with a live Russian band playing behind us, you're
I
a
was
sucker."
there. I was
You
there.
were what?
Absolutely. It was freezing cold. I came from Hawaii, and everybody, like the students there, were wearing shorts, and it was freezing. I couldn't believe it.
I can't believe you were there and we didn't meet at the time.
Yeah, exactly.
I mean, Waz and I were there. I got in trouble. But that's a whole nother story. But we and actually the kids that did that project, Soren Spies and the whole team there, we actually ended up hiring them at Apple. So we stole them, or a lot of them we kidnapped back to California.
Yeah.
But I can't believe we didn't meet. That was one
I
of
was there.
my favorite moments.
Totally there. I was totally there.
So
I mean,
that's a great
If that
segue.
ever happened, I'll be there too.
So that's a great segue from Alex Fielding and Privateer to Henk Rogers and Blue Planet. So Hank, you're up next.
All right. Just play a little video first, if you can. Do you have a video?
I believe
Somebody
that
has.
I believe that Michael has that. We'll see if we can get it up here.
If you can't, I'll start.
Why don't you go ahead and start, and we'll get the video up as soon
All
as
right.
we can get it up.
Okay, so gosh, it must be at least 10 years ago when, oh, there it is.
Oh, here it comes.
Never mind.
Sometimes Zoom takes a little while to get moving.
No
Don't do
sound.
much. No sound though. This looks like Mauna Loa.
Yeah, no sound. Let's do it again. Otherwise, I can just talk.
There we go.
Don't hear
Still
anything.
don't hear much. Why don't you go ahead and just explain what everybody's seeing?
Yeah, okay. So, a number of years ago, we had the head researcher from UH working to do a series of Mars missions for NASA. And she came to me and said, it's like, we have a problem. And I said, what's the problem? It says, well, neither University of Hawaii nor NASA can own a habitat. Could you please own the habitat and we'll rent it from you or lease it from you? And I said, sure, but if I own a habitat, it isn't going to be a piece of junk. She said, okay, it's your habitat, you can do what you want. So we looked at the designs, and basically we started from scratch because the team that was working on it had no chance in hell of completing the project. Nobody had ever built a toilet or a house or anything that people lived in. There were a bunch of engineers doing calculations on stress loads on a new kind of dome. And we had 4 months. So we spent 4 months, we spent a month designing, bought a dome from a company that makes domes, and built the inside in a warehouse in Kauai High, took it apart, brought it up to Mauna Loa at 8,200 feet, and the paint was drying, but we were ready for the first crew. By the way, the first crew, and when I say crew, I should explain what a mission is. A mission at that time is 6 people staying in 1,200 square feet. And if they go outside, they have to wear a spacesuit. And if they communicate with Earth, we delay that signal 20 minutes each way. On the very first crew, one of the crew members was Cyan Proctor. Everybody in here know who Cyan Proctor is. She's now like the hero that went in orbit with this SpaceX. So she's like super famous now. Anyway, we did 5 missions, 4 months, 4 months, 8 months, 12 months, and 8 months. And basically we ran out of missions. And so since then, we've repurposed the habitat. We don't just do Mars missions now, we do mostly moon missions. Moon missions don't have to last as long as Mars mission. And Mars mission is basically 8 months to go, 6 months to wait while the Earth comes around, another 8 months to come back. So it's 22-month mission. That's why we needed to figure.
It looks like your Hank's screen froze up. We might have lost him. But anyway, yeah, Hank hired a gentleman named Paul Pontio, actually as his partner, to do the architectural work and the engineering work on that habitat. And as you can see behind Hank's head, there's a photovoltaic array. And there's also a, they use the photovoltaic array, obviously, to supply power to this habitat during the day. And they also use excess solar energy to make hydrogen and store the hydrogen to run when batteries go low. Use that to run the habitat when there's no solar available. So it's a pretty interesting little microgrid or mini grid or off the grid house, if you will. And they literally make the space suits and the space apparatus that look like backpacks, so they have a weight they have to carry around. And it's a really sophisticated piece of work that they're doing on Mauna Loa. And for those of you that were around during the Apollo missions, a lot of the training for the astronauts back then was on Haleakala on Maui, because the terrain looks a lot like the moon, and looks a lot like space, and you have the same kind of restrictions. You just don't have the no atmosphere conditions. But hey, if you've ever walked around at 10,000 feet altitude, you can't do a whole lot of running up there because you'll run out of air pretty quick. But it's a good training environment as well. So when you look at the different kind of opportunities there are in the space world in Hawaii, we've seen a great cross section of those. We have the opportunity for military missions and contracted military missions and contracted government missions. We have okay, Hank's back now. Here's his audio came back in. You ready again there, Hank? Okay, you just have to come off mute and you'll be good. You gotta come off mute, Hank.
So my internet that got disconnected, I just switched to my phone, so I'm on cellular right now. Sorry about that. Anyway, that's kind of the story of how High Seas got started. It's located about a couple of thousand feet above Pohakuloa training area on the Big Island. And we're looking to get a piece of Pohakuloa because Pohakuloa is 100 and I think it's over 100,000 acres. We're asking for 1,000 acres where we can practice building actual moon bases. Now, when I say actual moon bases, I believe that MoonBase, there are 3 phases. Phase 1 is where we send up a rocket with a module, just like we did in the 60s, and we operate out of something that's pre-built on Earth. And phase 2 is where we send up robots and parts, and the robots assemble a dome or something like it, and then we pressurize it, and then we can move in once it's built. And number 3 is when we're actually operating out of the moon. I believe that we're going to start building underground structures. And the reason for underground structures is that it gives you instant radiation protection. It can also be a byproduct of mining of some kind. And the shapes can be anything. And so we're looking to have robotic termites that actually create these underground spaces. There are a lot of people who believe that we're going to live in lava tubes, but when you have a lava tube, getting stuff in and out of the lava tube is the easy way to say it is a bitch. And so we practice going in and out of lava tubes near our high seas habitat all the time, and this is really, really hard. So I think it's going to be much easier for us to build wherever we want to be. This is the other problem with the lava tube. The lava tube isn't going to be where you want it to be. It's going to be like, I don't know, miles away. Then you have to think about transportation to get from, where you're staying to where you're actually doing stuff. But you want to be on the lip of Shackleton to do mining of volatiles. So why would you want to be, I don't know, 50 miles away and go to work? That's just too much trouble. So what I'd like to do at Pohakaloa is practice not only robotically building above ground structures and then burying them, because you got to bury any structure you build on the moon with a couple of meters of regolith to protect the occupants from radiation. But we can practice going underground and building those underground spaces. Now, my ideal situation on the Big Island would be a pressurized habitat, pressurized so that the difference between the inside and the outside of the habitat is the same as the difference between the outside and the inside of a habitat on the moon. So you'd have to go through an airlock to get outside. Now, the other thing that's different, big difference between the moon and Earth is Earth has a sky. So it's bright and so on in the daytime. But on the moon, like we're going to be operating on the North or South Pole, which I believe that's where we're going to get started, the sky is always dark. There you can see the stars. The sun may be a bright object above the horizon, depending on where you are. And we can simulate that. We can simulate that by letting the astronauts, the practice astronauts, only out at night, and then simulating the Earth by putting a searchlight just above the horizon. So then you'd have to operate in the dark with long shadows when you're going out on your EVAs, and that's going to make it much more realistic. So the suits would have to be pressurized, the MoonBase would have to be pressurized, and if we got really clever, we could even bungee them with some kind of a superstructure so that they're actually hopping around and having to do the lemur walk, because that's what we found out, that normal walking doesn't work. You have to sort of hop around like lemurs do in Madagascar. So I really think that Hawaii, the fact that we have regolith on the Big Island, well, something like it, we're 90 something percent the same, 97 or 8% the same as lunar regolith on the Big Island. And so we should be able to not only learn how to build things in and out of lava tubes, if somebody still wants to do that, but to go underground and how to take the material and break it apart and use in situ resource utilization, ISRU stuff. So I think Hawaii, especially the Big Island, is the place to practice being on the moon and Mars, by the way. It's about the same. The reason it's a red planet is the same reason that our red dirt is red. It's iron oxide that gives it that red color. And so again, the moon may be white because there's no oxygen, but even on Mars, even though the oxygen is so low, it's over billions of years, there's enough to turn all of it red through oxidation. So the building materials that we find on the moon and Mars are similar to what we have on the Big Island. We can practice, we're close to Asia, so if we have partners in Asia, they can come and work with us. I really want to build a lunar university with one campus at NASA Ames, and we've been in that discussion for a long time, and the other campus on the Big Island at Pohakaloa. And by the way, Space Force guys, if you're going to be on the moon, you got to be underground. You can't have surface targets. You got to be, why would you build something on, a small rock would like wipe it out in a heartbeat. So anything that the Space Force is going to do on the moon is going to have to be underground. So that's my spiel.
All right, Hank, thanks very much. And thanks for your continued support of space ops there on the Big Island. I have a quick question for you. Do you see hydrogen playing a role in any of this kind of training and or as we go into space, any application for hydrogen? And that's a selfish question, but I'm asking it anyway.
Yeah, no, absolutely. There's a huge application. You know, we're talking about going to the moon and taking the ice and turning it into oxygen and hydrogen. We can take that stuff and store it, and that will be. I think that's going to be our primary storage. And the reason I think that is because carrying batteries, the amount of payload that it takes to send batteries to the moon is huge. And we can actually create our own storage using leftover tanks from rockets that we send to the moon as storage for the oxygen and the hydrogen that we create. And by the way, at the high seas, our primary, or how can I say, yeah, I guess primary storage, the storage that gets us through the night, short-term storage is our batteries. But if the batteries for some reason run out, we have a backup of hydrogen. Now, we don't make hydrogen at the habitat, we make hydrogen at the ranch, and we transport it up every once in a while. It's all, it's very little that we need for the backup. But if we were to have a moon base, it would be the other way around. We would be making the hydrogen right at the moon base and then storing it. And hydrogen, I heard earlier that it's dangerous and so on and so forth. It's not nearly as dangerous as any fossil fuel. So, I mean, there's a lot of misinformation out there. I mean, of course, if you mix it in the perfect ratio and then spark it, you get a serious pyrotechnic reaction. But hydrogen, being the lightest element on Earth or in the universe, if any of it escapes, it runs away immediately. It doesn't hang around. Fossil fuels or carbon-based fuel, all heavier than air. They hang around, they sink, they go down to the ground, and they find a spark somewhere, and then they work their way back to the tank. So again, hydrogen is so much. You're not going to see city blocks going up like you do with liquefied with natural gas. And there's so many things. They happen all the time where we're sort of like become, what's the word? We don't even care about it anymore because it happens so often. When cars, burn people up or, people die, it's because the car is full of a very volatile fuel. That's not going to happen in a hydrogen car. It just isn't.
All right. Well, thanks, Hank. And thanks to Lysine for rescuing Hank when his internet went down. We have one more presenter, a quick presenter, Susan Tai. And so Susan represents the Economic Development Alliance of Hawaii. And she's going to be talking to us a little bit about, how the role that they play in creating new industries and helping new industries come online in Hawaii. So Susan, it's all yours.
Wonderful. Thank you, Stan. I'm going to go ahead and share a presentation. And I'll try to keep this short too, as much as I can. But I'll go ahead and start with just thank you so much for the opportunity to join this. Thank you to Ramona, to HUD, to you, Stan, for inviting the Economic Development Alliance of Hawaii into this conversation. And what I'm going to present today, actually, let me just double check. Can you see my screen?
Yes,
Awesome.
we can.
Thank you. So I'll be presenting on the Comprehensive Economic Development Strategy, the CEDS, which is currently just about to kick off being updated to some different phases. The Economic Development Strategy, the CEDS, I'm going to jump right into just kind of showing you, relevant to this conversation here, just kind of how overarching and impactful it is for the entire state. The leadership and the stakeholders for this document, which serves as the economic development roadmap, so to speak, on the county level.
I don't know what happened, but the internet went down. The internet went down
No.
while I was giving a speech.
Hank, you got to go back on mute.
Sorry.
But the CEDS, right? So it is a 4 different county level SEDS are developed as well as a statewide level. And as you see here, this is actually thanks to the U.S. Economic Development Administration, or EDA, who funds this document that's updated every 5 years. In this case, EDA funds this to DBED at the state of Hawaii level, administered through the Office of Planning and Sustainable Development. And then OPSD then contracts EDA. And then EDA is a private nonprofit organization. We were actually started back in the 80s, but then became a formal nonprofit in the late 90s. And we are anchored by the economic development boards across the states. Hawaii Island Economic Development Board, Kauai EDB, Maui EDB, which Alex had mentioned earlier, and then also Oahu EDB. We're also anchored by Hawaii Business Roundtable. Many of you folks I see on this list of attendees have worked with Gary Kai and his membership as well. But just to show you kind of the level that we're operating on, right, from federal, state to county levels, and then all the parties that are going to be involved in the SEDS update are just across the board, from private to public sector, nonprofit, for-profits. We'll get a little bit more into that. But just to give you a kind of an overview of the process, the SEDS is really strategy driven as dictated by US EDA for economic development at a regional level. And it's meant to build capacity, guide regional economic prosperity, and it's very industry cluster based as prescribed by EDA, meaning that it's not just focused on industry clusters per se, but it's really, industry sectors, but it's really focused on the cluster, right? Because we want to acknowledge all the additional inputs and additional partners and players that really make industry sectors go, right? So even say, for example, food and agriculture, it's not just about the crop producers or the value added food producers, but it's also about transportation, about supply chain. It's about a lot of different inputs that will make the industry cluster grow and become successful. The SEDS isn't only about the initiative itself, but it also leverages other existing plans, other existing efforts that are happening or that have recently happened, so that we maximize awareness to those different constituents, but we also build these collaborations. So for example, community health needs assessment, or the dual use task force initiatives, definitely here in aerospace, especially with the work that Maui Economic Development Board is doing in situational awareness. Definitely just wrapping in a lot of different efforts and plans, just so that we're all primed to be able to collaborate when those opportunities arise. As I mentioned, there are 4 county level SEDS plans, and then those 4 county level plans are then wrapped into one document with a statewide plan, this overview and wrap up, so that you have one major document. As you can see on the right, those are examples of the plans that have been done on every 5-year increments as dictated or prescribed by EDA. Our first inaugural plan was done back in 2005, then the update in 2010, and then another update in 2016. Slight delay for federal budget reasons. We're currently in the process of the 2022 to 2026, and it's slightly off by a year, unfortunately, because of a lot of delays I'm sure everybody here has encountered with federal procurement and federal budget. The way that we do the update every 5 years is there is a statewide steering committee, and then at every county level, there's also a steering committee, and then all of these focus groups focused on the individual industry clusters. That framework of the plan for every industry cluster, we start off with a summary background. So thanks to Dr. Tian and his team at DBED, actually, they have provided, along with UHERO and a number of other different resources, kind of this baseline data to help us understand right now, what is the slice of the status of these industry clusters? Right? What's the status of our local economy? And as you can imagine, it's a very colored, multi-layered perspective right now, especially due to the impact of the pandemic from the last 2 years. So we start off with this summary background on each of the areas. Then we launch right into a SWOT analysis. It's done for each of the industry clusters. For example, here, a lot of the conversations that have gone on here, as well as other aerospace and space related and renewable energy and energy efficiency related conversations and initiatives that we've had the honor of being part of. Having that conversation is even more crucial now, that SWOT analysis, because to be able to look at what the status of each of these clusters are, but also who are the players, right? What have been the businesses in those areas and how have they survived during the pandemic? For those that thrived, how did they leverage opportunities in order to grow during a challenging environment? And for those businesses or other initiatives that didn't make it through the pandemic, what happened there? What were the threats that happened there? What were the potentially missed opportunities that happened? And so that analysis is crucial to the SEDS development. Coming out of it, we have to have a strategic direction and action plan. So it's not just a strategic plan, right? We don't want to have the SEDS be like one of those dreaded plans that so much effort has been put into it statewide with so many stakeholders, and then it gets shelved. And that's why it's a strategic implementation plan. The practical side of it's super important. And then there's that evaluation framework requirement piece where we have to set some performance metrics. In this case, although the SEDS document is updated formally every 5 years, EDA is committing to actually kind of doing a benchmarking and inventorying, like a progress tracking every year, because we really want to stay on top of, how effective has the plan been after all of this brainstorming, all of this direction and action planning? How effective has the plan been? How much is it being utilized? Who are the parties wrapping around it? And different performance metrics around how is it performing, vis-a-vis in collaboration with other initiatives as well. And this last piece is particularly important. Resilience is another required component built into the SEDS by US EDA. How they define resilience is both steady state and responsive. Steady state meaning, what are those long-term efforts that bolster the region's ability to withstand shocks to the system or avoid shocks to the system. But then also responsive resilience, meaning what's also the capacity building that's happening for economic development organizations and other support organizations or technical assistance, TA organizations, that enable them to help in that whole ecosystem of your region responding to recovery needs following an incident, such as the pandemic. I'm going to go right into just giving you an idea of the industry clusters, and these are very broad umbrellas. These are the current industry clusters that have been identified in the SEDS, from agriculture and food production, creative industries, healthcare, manufacturing, construction, energy, and the hospitality, tourism and visitor industry. We have these in, just over kind of almost Venn diagram kind of connections, because although the first two SEDS plans really focused on kind of identification, development, kind of fleshing out each of these industry clusters, we're at a point now with the last document that was done in 2016, and especially this one, where a lot of the work that's been done in these industry clusters are so mature that this is really beyond time where we really start to do cross-cluster collaboration. So again, I'll use food and agriculture. It's not just about crop production and value-added food production, but it's also about, infusing technologies into it to help reduce the margins for the producers, make their production much more effective and efficient. But then also infusing renewable energies and energy efficiency, for saving money and again, helping to streamline their operations. Creative industries, especially now you've seen during the pandemic, just kind of the need for more digital content and just kind of digital platforms to be able to transact, where during the height of the pandemic, so many businesses either temporarily or permanently folded because, they lacked that peer-to-peer ability to transact. And then the overlap with healthcare as well. Food and ag, has such a natural connection to healthcare in terms of the health, in terms of diet regimens, but then also, especially in Hawaii, there's that component of the culture, the Hawaiian culture, and what it means, food and crops and land caring, land management. So that's why you see these industry clusters in such an overlap. I'll just mention too, it's a very broad framework for the SEDS as well, because we're not just solely focused on the industry clusters themselves, the cross-cluster collaboration, but it's also this broad framework where the SEDS actually touches on business development, small business as well with a focus, because it's such a vast majority of the numbers and types of businesses here in Hawaii. But also entrepreneurship and innovation, which has been, a very strong theme in today's conversation. And also education and workforce development, because that educational pipeline, as we've been working with several different entities, working with the university, working with Workforce Development Council, and just working with the broader business community, it's so important, right, to frame that educational pipeline to provide the individuals, right, to provide that workforce for these fields. How do we leverage that? How do we connect actual trainings that really reflect what the market's needs are? And then that last piece here, just SEDS again is all inclusive. So public and private sector, non-government and nonprofit sectors, everyone is invited to participate. And although EDA and its EDBs actually produce the regional SEDS and the statewide SEDS, we don't have any kind of ownership or proprietary feelings about the SEDS in that we have to manage all the programs that come out of it, or we have to oversee and prioritize those projects. We really, really want the community to come be part of this process, and where you have relevance to your organization, whether you're ready to take a leadership role or participate, as one in a group on discussing and building out the projects and how to move forward, definitely contact us and we will help connect you to either your region or to the broader industry cluster groups. Here's some examples. In healthcare, the research, innovation, and tech piece, the food and ag piece, creative industries, renewable energy, and astronomy, aerospace, and aviation. These are kind of the, I just kind of plucked some of the broad initiatives that have been outlined in the plan. What I'll do also to Stan and Ramona is I'll send you guys the link and you can share it with the group of the last SEDS. These are some of the initiatives that have been identified from the bottom up, from the grassroots up, coming directly from the community, right, of examples of projects that they really feel is important in developing these strong regional collaborations to focus in these areas, and these will trigger critical growth in these industry clusters. And I won't read through all of them. And I think, Stan and Ramona, I think you guys are sharing some of the slides that are provided today, but definitely feel free to share this with anyone. And I'll provide the link to this. But these are just some of those examples, right? Again, involving public-private partnerships, involving education, workforce development, incubation and business development services, especially like in healthcare, investing in telemedicine. That has been extraordinarily important during this pandemic, right? Where there have, in an epidemiological crisis like we've been experiencing, the investment in telemedicine has been super important. And just as an example as well, we also, you'll see threaded throughout the SEDS plan, is also a focus on broadband infrastructure. Because again, if we're saying coming through and hopefully out of this pandemic soon, the need for digital content and digital venues and platforms for businesses, right, to be able to transact or to open up markets where they haven't tapped into before. To do that, you also need connectivity and bandwidth. And so EDA is very involved in supporting the broadband initiatives that are happening at the state level and also at the university, their leadership as well.
Great, Susan. I really appreciate your presentation. We only have a couple minutes left, and I wanted to thank everybody for their presentations. We pretty much answered most of the questions that came through on chat, with the exception of one on Ukraine, which I think may be a topic that I could go on for about a half hour on, but it may be a little bit big. But space is a really important future perspective industry for Hawaii, and I'd like to thank all of our presenters, Eugene, Hank, Alex, Ryan Okahara, my pal Ryan, and Susan for putting this together. Lacine and Danielle for coordinating with Alex and with Hank. And I'd like to give the last minute to Michael Markrich to kind of close out for Renew Rebuild Hawaii. So Michael, it's back to you.
Hey, I'd like to thank you all, and I want to invite you to our next meeting, which is April 28th, which is going to be on carbon capture, taking the carbon out of the atmosphere. So this has been a very tragic week with all the things that are happening. The world is changing faster than any of us can ever imagine. This is the ultimate black swan event that we're living. And I want to thank you all for taking the time out of your day to be with us, and hope to see you again. Thank you.
All right, I think that's going to do it for us today. again, thanks to Alex and Hank and Ryan and Susan for their presentations and the questions that you folks did send in. And for Renew Rebuild Hawaii and me, Stan O, thanks for being with us. Aloha.